we're actually going to continue this theme of DeFi and kind of how do you actually make sense of all the stuff that we're seeing, especially the proliferation from all the different chains and rollups out there. So we'll continue this with our next talk. And for this talk, I'd like to invite Amir on stage from 0x. He's the co-founder of 0x. You may know them mostly from the product called Matcha. And he's going to talk about how simple DEX aggregation is with an asterisk. So please give Amir a big round of applause.
Thank you, thank you. Quick show of hands so I could calibrate the presentation a little bit. Who here knows what DEX aggregation is? Okay. Who here knows what MEV is? Okay. Who here knows what a solver is? Okay, pretty good. Cool, well, yeah, today, as Kartik shared, I will be doing a presentation on why DEX aggregation is harder than you think. So for those of you who aren't familiar with 0x, we started building liquidity aggregation technology in around 2020. We've been around since 2016, working on DEXs before that with a very different model. In 2020, it was a very different space. Ethereum was pretty much the main blockchain that was being used at the time, and we built the first version of our liquidity aggregator. We finally upgraded to a brand new architecture just last month, and I wanted to talk about some of the design decisions that went into that and some of the learnings that we had from the first model. So yeah, first I'll just give a brief overview of 0x v2 and then everything else. Cool, so yeah, as I mentioned, 0x v2 is our latest liquidity aggregation API. We worked on it for over a year. It was pretty much an all-company effort, all hands on deck. It's difficult to prioritize such a large change within the company, but we decided that this would be the most impactful thing that we could possibly do, given that we were on this very functional but legacy architecture from before. Our smart contracts, our pricing engine, and our APIs were completely redesigned to address the biggest pain points of our customers and our own internal pain points, which ultimately end up impacting the customers. So yeah, I'll get into some of the features and the metrics that we designed 0x v2 around. First things first is the pricing engine. Pricing is, well, Argon is the name of the router that we use internally and externally. It's a very fancy pricing engine. Pricing is king. Everyone knows that generally, if you're using a DEX aggregator, you're doing it to get a better price. It's the first thing that comes to mind. It's table stakes to have very, very good pricing. And it's a very difficult problem. Routing is not a solved problem. There are a lot of academic papers out there, many of which we used in recreating our routing, but they're generally not adapted for blockchain environments, and it actually takes a lot of effort to build them out in the right way. Routing matters a lot for large trades, especially on Ethereum where gas costs are pretty high, and it matters for basically all trades on the cheaper chains. You could do like a $20 trade on some really cheap chains and you'll just have like an insane looking route. There's sometimes a narrative that it's not worth using an aggregator because like it's just gonna go to Uniswap or whatever and gas costs are higher. That's like a 2020 narrative. Like that is just incorrect today. There are hundreds of different decentralized exchanges out there and you will not get the best price unless you're using an aggregator. And today they're also very optimized for gas costs and such. So yeah, Argon uses a combination of published and unpublished techniques. I am not going to get into those today. If you are interested in a more technical deep dive of different routing methodologies, you could check out this other presentation that one of my colleagues, Duncan, gave at, I believe it was ETH Denver earlier this year. And also follow this Twitter account, X account, Matcha routes for some beautiful routing art, which I will show you in a second. These are just some pretty crazy routes that we see in the wild today. These are trades that actually happened. You could also go to Matcha XYZ, our consumer-facing DEX aggregator, and you could just see the routes for every single quote that you get. It's these exact same Sankey diagrams. So here's an example of a $50,000 Matic trade. Not a huge, crazy trade by any means, but you could see it's just like a pretty insane route. Around $400,000 Pepe trade on mainnet. As far as mainnet goes, that is not a huge trade, believe it or not, but again, a very crazy route. And then finally, $1.8 million WETH trade on Arbitrum. Again, pretty crazy route. On those cheaper chains, you will see some pretty interesting things. This one I feel like I could hang up on my wall. All right, well, with good pricing also comes a lot of challenges. Routing introduces new complexities, the first one being latency. When you are trying to find really, really crazy routes and utilize as much liquidity as possible, you're scanning thousands of different liquidity pools across hundreds of different DEXs and trying to find the exact right combinations to get you the optimal route. That is just a huge search space of possible routes, and generally as routing complexity goes up, so will latency. And latency is really important for DEX aggregators, and I will get into why that is exactly. Also, kind of a lesser known issue is quote accuracy. So when you have really crazy routes, there is a possibility that your quotes will actually just be incorrect, and you're going to be showing users a price that's often too good to be true. So why does latency matter? As routing complexity increases, you need to get latency down. It's a constant battle. It's really important for consumer-facing apps. There are a lot of studies just like in consumer apps generally, like not specific to the Web3 space at all, that the lower latency you have, the better your user conversion is going to be. But just from a trading perspective as well, there are a lot of reasons why you need low latency. So there are a lot of solvers and trading bots that use DEX aggregation APIs in these auctions, these intent-based auctions. And if you are participating in an auction that is only a few seconds long, like obviously latency needs to be quite a bit lower than that. Also, a lot of these newer chains, cheaper chains, have pretty fast block times. If your latency gets out of control, then you might just end up with stale quotes, right? You generated a quote at block X, it's already block X plus 10, and that quote can no longer be executed. I don't think this is something that people generally think about when they think about DEX aggregation, but there is, trust me, a lot of work going on behind the scenes to make sure that latency is under control. Quote accuracy, this is more of a hidden problem. I feel like this is, I don't know, kind of the dark forest of DEX aggregation, because often users are getting, I would say, unintentionally deceived. So there are kind of two categories of quote inaccuracies. One is just you produce quotes that are too good to be true. They cannot possibly be executed. And the second class is you produce a quote that could hypothetically be executed if you did it at this exact second and there were no other transactions before or after. But in actuality, there's a very high probability that that quote will not be executed for a variety of reasons. So I'll explain the too good to be true quotes a bit. First of all, depending on the routing algorithm you use, it may or may not be possible for it to just simply find routes that are too good to be true. They're just kind of false positives. Argon is built with a constraint that it cannot do this. Other routers that we've seen, some pretty big names, just actually don't check to see if their quotes are valid, and they generally do this to get latency lower. So they're just kind of taking shortcuts, and in a way, it's a win for them because they show users prices that are too good to be true, and the users might end up going with that. But for us, trust and accuracy are really, really important, and we are making sure that we are validating all quotes to the best of our ability. And then finally, if you're using any intent-based decentralized exchanges, they are notorious for this problem because generally they are only showing you an indicative quote of what you can get. You can't actually just like take that quote and execute on the blockchain. You just need to see a price, say you're okay with it, sign that intent, and then an actual auction begins and a solver or a filler will try to get you that price. But at times that indicative quote could just be wildly off. I've definitely had the experience of seeing a quote that just like looked crazy, and I'm like, all right, I love Matcha, but like I'm gonna save thousands of dollars by using this. I'm gonna do it, and then I just like sit there waiting for 30 minutes for my order to get filled. It never does. Price moves in the meantime, and I get screwed. So it's a really bad user experience, and I think it decreases trust in products. But generally, these apps are not really getting punished because it's not a very visible problem. So again, we are validating quotes to the best of our ability and generally not producing these. And then the other issue, you have quotes that technically can be executed, but they just will realistically not be executed. So if your routing is really crazy, you could actually find arbitrage opportunities within the routes that you calculate, but we know that the space for MEV and arbitrage is extremely competitive, and good chance that when you go to fill that order, someone will have already captured that opportunity before you, so you might as well filter those out. Also, different liquidity sources are just more or less susceptible to MEV, and you might want to account for that in your routing for different types of pairs. And then finally, some routes might just be too crazy to realistically be executed, especially on a faster blockchain where things are moving really quickly. These are metrics that we are looking at all the time in simulations when we are building or improving the routing, and we have definitely the best quote accuracy in the space across both of these types of quote inaccuracies. V2 also has enhanced coverage and security. What do I mean by coverage? So the amount of combinations of things you can do in the blockchain space is just like growing at this crazy exponential fractal rate. There are constantly new chains being launched. I mean, you could probably launch an L2 in like 30 minutes these days if you really wanted to. There are all these different new types of tokens, like fee on transfer or buy-sell tax tokens. And on each of these chains, there are all sorts of different types of liquidity sources or decentralized exchanges. So what we mean by coverage is, as a DEX aggregator, you, in an ideal world, want to support all of these things, but the complexity is just increasing at a crazy, crazy rate, and it is very difficult to manage. Coverage and security go hand in hand. So this is something we discovered as well in version 1. So we had this upgradable architecture, and it worked well for a while. But back when we launched, there were probably like 5 different liquidity sources, and we kind of saw where the puck was heading, but didn't necessarily expect there to be like hundreds of different decentralized exchanges. And we would roll out upgrades relatively frequently, but then just the number of code paths of things that could interact with each other also grew exponentially, and it became very difficult to add new features without or while feeling confident that security would not be an issue, that you would trigger some like random unknown code path. So we designed a brand new architecture for our smart contracts where there is virtually no risk to the end user, and we could essentially upgrade as frequently as we want. We are generally upgrading the smart contracts every 2 weeks now. So with these low iteration costs, you can now increase coverage, which ultimately ends up benefiting the customer. I've had this conversation so many times with version 1 where a decentralized exchange would reach out to us and be like, hey, can we get integrated into Matcha or 0x? And we would run some simulations and we'd be like, all right, so this is gonna improve pricing by 1 basis point, in this one trade size bucket for like these 3 token pairs, and it's gonna take a week of effort. So in isolation, those things are just never worth it. And we kind of fell behind in adding new liquidity sources. Now it's extremely easy for us to do that in a very secure way. Could do it in a matter of hours. So we just have all of the liquidity sources and we are, keeping up. So overall, V2 is built for security and for scale. So what is this new security architecture? How does it work? In V1, we had this monolithic smart contract that would get upgraded over time, and everyone would set their allowance to this. So as I said, adding new things became very scary because if anything went wrong, poof, billions of dollars lost. In V2, we use this new permit to architecture. So we only ever ask the user to set very short-lived ephemeral approvals. So their funds at risk, or their funds at rest will never be at risk. You can't be sleeping at night and like all of a sudden your wallet gets drained because you actually just don't have allowances set to our smart contracts at all until the point that you are ready to make a trade. There's also another smart contract called Allowance Holder, which is more of a traditional familiar flow, which I will get into in the next slide. I already talked about permit to a little bit, running low on time, so I'm gonna try to speed through. Allowance Holder is a kind of an intermediate contract, which you set your allowance to, and it, sort of just, because it's like a middleman holding the allowance and you're not interacting with the actual settler contract, again, this creates a barrier so that your funds at rest will never be at risk. So with expanded coverage, we've been able to ship more quickly. V2 includes support for fee on transfer tokens. This is an idea that's been around for a while, but recently really took off with the meme coin mania. So these tokens have a tax built into them. If you buy or sell the token, you might have to pay a couple percentage points. Didn't think that would last, but it did. And now that is supported in V2 in a very efficient way. We have definitely the best coverage of meme coins out there. And we have also rapidly been adding new blockchains. So since launching about a month ago, we already added 4 new chains, and we have 6 or 7 more chains on the roadmap by end of year. UX and DevX. So these are just some kind of random pain points that we discovered ourselves and through customer conversations. This one is for all the finance guys in the audience. So when you have a swap feature in your app, you're monetizing it, you're collecting fees in all of these different tokens, and then you realize you have like 100 different tokens, 200 different tokens in your wallet, and you need to sell them all into stablecoins at the end of the month. And this is a very onerous process. Most DEX aggregators don't really allow you to pick which token you charge fees in. It's hard to do in a gas-efficient way, actually. But yeah, this is a highly demanded feature that is now supported in V2. So now you could just take your fees in like USDC or Ether or whatever, maybe 5 different tokens, and you don't really need to go through this onerous hedging process. You're also no longer paying gas costs to hedge those tokens. And we also have enhanced quote validation. So this builds trust in the quotes so that you can know that they are accurate. We validate the gas costs very precisely. Fun fact, we actually discovered that some of our users were literally using our API only for the gas estimates. Turns out that is actually one of the harder problems when going multi-chain as well. And we also have a new field in the API called issues, so it'll tell you exactly what went wrong and what steps you need to do to rectify that for your users. Moral of the story, don't roll your own DEX aggregator, get serious, use Matcha, use 0x. Thank you everyone for the time.